Hey everybody. So yesterday I got the animation, sort of fixed a bunch of weird little bugs that were happening, and I added the selector in the animation so that you could select which property you were looking at. Um, and then I had mentioned adding the Z position today, but I ended up deciding that I didn't really like the way this table looked, and I wanted to use the material table, and I think that makes sense because one, first of all, like for a consistent look. So so when you go to the meshes, that uses the material table, and so just to kind of maintain a look between the tabs without having to put too much effort into that. And number two is I always struggle with material tables, and historically I've always had to just kind of take the material table example, copy and paste it on whole, and then slowly work backwards to have a working one. And this was the first time I was able not necessarily copy and paste, just rebuild my own material table. So I think I'm starting to understand that a lot better, and that's kind of the point of this application. Um, Material table is pretty awesome, but it is insanely um, opinionated, and you have to do it exactly the way it wants to be done, or you will suffer the consequences. But so as I do, I'm going to go over the the animation first, and then I'll go over the code changes. Um, the So the general, so what I have, let me show the raw data is, it'd be kind of cool to have the count on here just for this. But I have 1, 2, 3, 4, 5, 6, 7, 8, 8 meshes. One of the meshes is the light mesh, and then the ground mesh for things to um, for these things to be able to uh, have a shadow on. So like if I go into the editor and I change the ground to like -3, see, then the shadows get bigger because it's farther away. -4, and then like let's say -1. They're very close, and the light is brighter on it. So I believe I had -2 to start. I think that looks nice. And then basically I have these right blue, left white, that, and so then I made it to where they're sizes. I thought it just looked kind of cool. So the red one's in the front, so I'm just going to go to the red one, and I made the width 0.1. So let's go ahead and make the height 0.1, and then the depth 0.1. And so that's a teeny little dot, so I guess that's probably too small. So let's go with 0.5, 0.5, 0.5. So I didn't do anything with the scene. I didn't do anything with the camera. I did add 3 lights, and then I put this mesh right on top of where the light is, just so you could see, mentally where this. So the light is this far away from this left blue one. So let me pause that. So like it's very close to this guy, so his shadow that's cast is tiny and close to him, and then it's very far from this one, so the shadow cast is far, large and far. So that's pretty cool, and a good way to sort of understand what's happening. Um, then I haven't tried this yet, but let me go ahead and change the camera so that we're looking at it. So basically, the camera's sitting on top watching this thing go down. So if I move the camera instead of to sitting at 5 um, on the Z axis, so we're basically in front of it. If I changed it to negative, let's say -5. Okay, so now we're up 5 on the Z axis and then 5. So Now let me turn the animation on, and then you can see. And you can see the ground isn't quite big enough to cover the whole screen anymore. And then let's go ahead and go back to the camera and move this to 0. So it's coming right at us. And then like we can't really see anything. So we are sitting at -5 and on the y axis and 0. So let's go ahead and add a light there. And then make it -5. All right, so now the camera, right where the camera is, light exists too. So you can kind of see the changes. I think this is very, very cool. These are all Fong materials, and except for the light. And yeah, it's cool. Very cool. I'm very happy with this. Let's see. I'm going to move it just one up on the Z, so we're kind of watching it. And then maybe try it at -1, so it's kind of going over the top of us. Although it's kind of weird because it inverted everything. I don't really understand that. Like the ground is above us now, and maybe it's because of, I don't know. You know, that's interesting. I would love to understand that. Let's have it look up 1. Yeah, that didn't help. Let's see. What if we look up -1? No. So anyways, that's definitely something I don't understand, is why it would be inverted, why the ground, why -1 of y when we're down here is -1 of y is above us. That's weird. So technically, I guess what I could do is I could take the ground and make it positive too. So yeah, the ground is above us, and then if I take those lights and make them -2. So this is super hacky, right? -2, because I'm kind of getting my desire, but let's see, let's go update that one mesh, the light mesh, to -2. So I'm kind of getting what I wanted, but yeah, but still we're above it, and I wanted to kind of be below it, watching it kind of go over the top. Yeah, who knows? So definitely going long today. Well, there's really not a lot of code, so maybe we'll get through it. I did want to kind of show a bug, though, or kind of a weird thing to deal with. So in the code, if you look at the animations, basically all I did was make this table a matte table. And you can see it looks nice. And then this one, you know, doesn't look so nice. And so the X's never change, so we're not seeing the changes. But let me see, Y position. So now these are cut off by 2, and that was done with a pipe. So if you look in here in our matte table, basically get current. Let's see. Yeah, I think I need to, yeah, I think I'm going to give up on making this in 10 minutes. And then I don't know exactly the best way to. So, oh, and that was a problem. So in the matte table, basically what I do is, where are you? Oh, I add this pipe here, and that's what got it down to 2. That's why this is only 2 wide. And so like if you collapse this, let's see, I can collapse this, and you collapse this. Basically, we have 2 tables, right? And this is just a standard HTML table. And then this one is a matte table. and it's a mat table because we're using the directive up here, and then we're tying it to table source, and then each column is represented in this array. I'm going to get rid of that console log while we're here. So there's an array, and it just says, hey, we're going to have an ID, a name, a start, and end in a current table. And so basically there's kind of three major parts to this. You have your, I don't know, for your containers that describe the content of the header and the rows, right? So we know all we're going to have is an ID, and we're going to show the data ID, and we basically give it the name data. See, that's the funny thing, is so we give it the name data right here. So you kind of down here on this container. Oh wait, no, we don't. Oh yeah, we give it right there. So that's how we defined that the things that come from table data are called data, and then in there's a data ID, and that'll make sense in a second. Now here we go away from that pattern, because we need the live update of the name. So basically, when I had something like data.name, I'll show you. And if I come over here to here and I add a mesh, and then I edit it, and then I go in here and I call it, I'm going to make this bigger and refresh. So I'm going to add a mesh, and I'm going to edit it, and then I'm going to expand this, and I'm going to mark it as animated. And so now it's in our animated list, right? We have a list, and oh, I didn't interpolate it. So I'm going to interpolate it. So I don't know if you noticed that, but basically when we, let's see if I can fix that again. There we go. So before, when we didn't interpolate, what happened was it just showed the text, but now we've interpolated and re-signed it. So basically, if I mark this as animated, we come in here, and so basically there's nothing there. And then if we come back over here, and then we change the name to AAA, and then I come back over here, it hasn't been updated. So this one updated, this one did not. And that's because I don't know exactly why that is. It's a real pain in the butt, though. And I see this happen all the time. And what's really strange, okay, so anyways, so we don't have, what's really strange is we do not have that problem on any of the other meshes. For some reason, this will not update automatically. So what I had to do is I had to add a new getter, basically, that gets the name based on the ID. And technically that's not a getter, but a function that gets the name is the technical thing. And so if I add this functionality, and then I go ahead and edit it, mark this as animated, and then come over here, note that it isn't updated, come back over here, change it. So now we get our name. And I run into this. When I used to work as a software developer, I used to run into this all the time. It was a real pain in the butt. That just sometimes I still don't really understand all the ways that the data, what causes the data to get updated. So, and you kind of have to pick your poison, because the reason this is happening is because over here in this effect, whenever our value changes, we create the table data. and we do a mapping of it. But we only do that. I only do that if this length is different. So if the length is the same, I leave it alone. And the reason I did that is, and I'm going to show you, um, is because, okay, so if I get rid of that functionality, what happens is if I go to mesh and I add a new mesh and then I edit it, then animated, and then I come in here uh, and I start changing things. See, I lose the focus, right? Like the focus is lost, and that's because this mapping is overriding what the change we just made. So this is sort of just a hack to make that behavior not happen. But it's very strange because if we look at the mesh manager or any of the other managers, we do a very similar thing. We update the mesh list, which is what drives the table on the effect. But for some reason, in that case, in the mesh, we can make changes all day long, and it doesn't update the form on us. It doesn't. We don't lose. We don't lose our focus. And even though the same behavior is happening, but there is no mapping, and the map. So then, okay, so then your question is, okay, so why are we mapping this? Well, the reason we're mapping this is because the table has a very specific way that it wants the data to be loaded. It wants you to give it a list of arrays, a list of columns, and then it wants to render the table based on that list of columns. So that means your data has to be nice and linear in exactly the same way. There can't be like deep embedded paths. You can't have the pair. So, and then the way we're getting the data is as a interface as a pair, and the pair is a pair of complex. It's an array of two complex objects. So, as you can tell, I'm very much struggling with the words here. And that is kind of the point of doing all this, is for me to actually truly or get a deeper understanding of how these things works. So this animation pairs has to be remapped into basically a new, more reasonable interface. And so this is the reasonable interface that I came up with: an ID, a name, a start, an end, and a current. So I do this mapping on that, and that seems to be thrashing the whole table. Whenever we come in here, the whole table gets thrashed every time you make a change. And then whenever you make that change, basically, so let me just see if I can put this in a way that makes sense. So I make this animated, I come in here, I make a change to the table, and I already have it back. And then what would happen would be that the whole table would get remapped, and then the whole DOM object would be destroyed and then recreated, and then it would lose the focus. So I had to add this. This is a very, the way this whole application is architected works beautifully, because the only way you can add a new animation is to come in here, create a mesh, and then when you create that mesh and then you mark it as animated, you're gonna change the size. If you delete the animated mesh, you're gonna change the size. So this scheme for determining whether a mesh or whether the data is changed within this or not, it works perfectly. If you could add from here, or if we ever come up with some other thing like a pop-up or some other way, this is going to break. And then if that breaks, and I actually added a comment here for myself, if it breaks, then we'd have to come up with a different way. And like I have seen like some places where the way they'll do it is they'll sort of keep a state flag that marks that, hey, we are actively working in this tab. So don't do an update or whatever, or check, or you could set up a hash that where you do an examination of the pairs and see if there was a change other than the change that was made within this. There's a lot of schemes, but this is a general problem that I see any place, almost every place I've ever worked where we use tables, and then you decide you want to make changes within the table that's going to affect that, and you're doing some sort of mapping for that. And if you don't do it that way, then it all seems to work under the covers. It seems to be coded to work perfectly fine. So yeah, I would imagine this that anyone who's sort of watching this is probably more confused than they started, and this is definitely one of those edge cases that is very, you just run into, you know, you run into it everywhere you go, but then you come up with sort of a novel solution. It seems to be there's a novel solution everywhere to solve this problem, but then, um, and it's like it's just yucky. But anyways, I don't think there's a good answer for this. Another possibility is like if the parent, um, if the parent component does this mapping and feeds this thing. So instead of us mapping within here, we map outside of here, and then we're feeding the application. Then that seems to also solve the problem. But that really deeply couples the components together. One component like the child component can't live without, like you, if you want to use this child component as part of another component, you can't, or you have to do a bunch of other coding to feed it properly. So yeah, this is just one of those like warts that happens, and it generally leads to really really nasty pull requests where people are arguing and wanting things redone, and then deadlines start to loom, uh, and then at the end someone throws up their hands in frustration and they finally go with some cheap hack like this. Um, I just don't have any good answers, but uh, at least there is an answer. Sometimes there are no answers. So on the bright side, of your silver lining, that's what that's all about. Happy coding, everybody. Bye.